Welcome to another session today. We're going to talk about using SOLIDWORKS Industrial Designer, the process, and how we develop that form, function, and usability inside of SOLIDWORKS Industrial Designer. In order to kind of set the stage for this, it's important that we kind of look at different aspects of both the process and the product Industrial Designer. So for our agenda today, we're going to start out talking about the 3D Experience platform. For those of you folks that are online that may have never heard of the 3D Experience platform, or some of you may be very familiar, I want to clarify exactly what that means. We want to talk about a part of Industrial Designer that bridges the gap between other products that you might be using. It's the concept sketching inside of Industrial Designer. Then the meat and potatoes, the Freeform Design, creating those organic shapes using subdivisional modeling, which comes in Industrial Designer. You're going to get a good look at that. And then, of course, we need to talk about its interoperability with SOLIDWORKS Desktop CAD. Just to be clear right off the bat, this is a complementary product to SOLIDWORKS. These two products can be on the same desk or a coworker's desk, and you can communicate back and forth between you. You're going to see a little bit of how that works today. So let's start out talking about 3D Experience. Now, 3D Experience, obviously SOLIDWORKS being a Dassault company, 3D Experience is a big part of Dassault Systems. But let's boil it down to exactly what 3D Experience is. 3D Experience is really a platform, very much like Windows is a platform. It's a platform for working and collaborating on the cloud. Now, the nice thing about having a platform is people can develop software that runs on your platform. And there's already tons of softwares that run on the 3D Experience platform, including other CAD softwares like CATIA from Dassault Systems. So the platform itself is made up really of two types of applications. Now, I'm going to use the term apps. We're so used to this when we talk about phones and tablets today, but the platform has cloud-based apps. So when I say cloud-based apps, it means there's no local installation. They're already available. When I log into the platform, I have things like 3D Space, which is where I store my data, 3D Swim, which is how I collaborate on my data, and 3D Dashboard, which is kind of like an internal intranet where it brings all the information and analytics to you. So those are all cloud-based apps. Then you have client-based apps. Now, we currently have two of them. Today we're going to talk about SOLIDWORKS Industrial Designer, but there's also SOLIDWORKS Conceptual Designer for mechanism design. Now, the client-based apps actually get installed locally on your machine. Now, as a SOLIDWORKS reseller, we have other platforms too, don't we? We have SOLIDWORKS Desktop, which is for desktop PCs. We have eDrawings, which is for PC, Mac, and mobile. We have DraftSite, which supports PC, Mac, and Linux. What 3D Experience does is it brings the cloud to all these other platforms. You will actually see there are connections to both SOLIDWORKS, eDrawings, and DraftSite to connect it to the platform. Okay. Now, I mentioned a few of the apps on the platform, and I'm not going to go through all of these, but there are a bunch of them that are just included when you get access to the platform. Everything is controlled by a single sign-on they call the 3D Passport. You can sign on from anywhere. You're sitting at a coffee shop in your hometown and you have access to a computer. You can sign on through that computer to the platform to contribute to the process of designing product. Okay, we'll talk a little bit more about some of these as we get going. Now, the centerpiece to the platform is something that you've probably seen all throughout SolidWorks and Dassault's material on the web. It's this thing called the compass. And what the compass really means to us in the platform is it's a way we get access to the different applications that we're going to use. Now, each of the symbols means something, and I'll go through them real quick here. The right side is information intelligent apps. I talked about this app called 3D Dashboard, which is like an intranet. It brings a bunch of information to you. Well, I can get access to that by clicking on the compass button for IIA. At the top is my social and collaborative apps. This is how I communicate and collaborate with other users on the platform. 3D Space is where I store the data. 3D Swim is how we talk about the data. Then we have really the side that we're focused on today, which is our 3D modeling apps. This is where I'll get access to SOLIDWORKS Industrial Designer. At the bottom, this is where we have our content and simulation apps. This is where you'll see Simulia product design simulation and simulation products that are coming soon will be on that portion of the compass. In the center is a play button. If you hit play, it will perform some operation, sometimes as simple as just rotating a model through standard views. Now, understanding the interface is very simple because once you learn how the interface works on the platform, all applications within that platform work the same way. Let's illustrate this for a second. What I am in now is my dashboard. Now, in my dashboard, as I mentioned, the platform interface is the same. I'll see in the left-hand corner what we call the compass. So those are the different buttons. As you see me kind of roll over them, they highlight. If I select any of the buttons, it shows me at the bottom what applications I have available for that particular section. And you'll notice in here is under my 3D modeling apps. Now, to bring our conversation all together, we have our connection to DraftSite, our connection to SOLIDWORKS, and our connection to eDrawings in here, along with our industrial design application. So the compass kind of controls this side of the interface. Now, off to the right-hand side on the top are a series of buttons. The first button is called the Me button. This is all about me, the logged-in user. It tells me what roles I have on the platform. There's some instant messaging that occurs on the platform when you have multiple users, but it's all about me and my single sign-on. Next to that is the Add button, where I can start to add things like adding a new file to industrial design or adding new things to the platform. Then we have a Share tab, which allows me to share. This will allow me to do things like exporting information from the platform into SOLIDWORKS. I have a Home button, which allows me to switch to different areas. And then I have Help. This area will exist in all packages that run on the platform. Now, at the center of the interface is the search bar. Now, we don't browse to something inside of the platform. We search for it. You'll see this in some of the stuff we're going to do later. And it uses something called the 6W tags. Who, what, why, when, where. It's like custom properties, but we're searching on those properties within the platform. Okay? Now let me switch over to industrial design. So now I'm going from one application to another. It's going to look very similar. You'll notice the compass in the left, the search in the center, and all my buttons that I just described on the right. Now where it starts to become very similar to a SOLIDWORKS user is off to the left we have a design tree. And very natural to me, the design tree starts with my standard planes and my origin. My features exist below that. My sketches are here. The hide show icons are to the left. I can collapse it. I can expand it. If I right-click on any item in there, I have edit. So it's very, very natural to pick up and use the design tree because it's very, very similar to what we do inside of SOLIDWORKS. One major difference is there is no difference between a part and assembly on the platform. You can take a sketch, turn it into a body, turn it into a part, and then do the same thing again to turn it into an assembly. So it all is one file with the same extension, no worries about parts, assemblies, and relationships. Now obviously you have the work area. All the pan, zoom, and rotate in the work area works exactly like it would in SOLIDWORKS. Off to the right-hand side of the interface, you'll see panels very similar to the task pane. In this particular case, the example we're going to show today, we'll use what we call our 3D swim communities to talk about the products that we're designing. And then at the bottom of the interface is something we call the action bar. The action bar is very much like some tools that we have in SOLIDWORKS, tab-based commands. I make a selection on the command and it shows me the individual commands that are available within it. So this whole idea of understanding the interface is very easy for us to go from one application to other, or even SOLIDWORKS to industrial design and get going. Okay, you're going to see a little bit more of this in a moment. Now let's dig deeper to today. Let's talk about SOLIDWORKS Industrial Designer, the product. We can't really talk about the product without talking about the process. Now, the process that I'm going to lay out here may not be everybody's process, but this is very typical in the industrial design. It's a little bit different than mechanical design. If I'm just designing a fixture and so on, there's aesthetics, there's other people involved in the process typically. So let's say I'm designing a new product, a new toaster that I want in the market. I might have to research about what other products are in that space. I would then have to define the problem, what I want to solve with my new product. I might come in there and try to differentiate my product with some new ideas, USB chargers built into your toaster, or a different shape, or anything like that. Now, what's my value proposition? Am I selling this to, high-end stores? This is for small apartments? Is it for what type of product do I want to sell? Then we select our concept, we make it aesthetically pleasing, and we make sure it meets up with any other product lines that we might have. Now, if I need to change or redesign, I start at the beginning and go all the way through again. Now, that process, I'm going to kind of bring that back together to what we traditionally feel in SOLIDWORKS or in the CAD world. That process is made up of, I have 5 different areas here. Let's say hand sketching. So if somebody grabs a piece of paper, starts to sketch out something, then they might go into something called 2D composites, where there's a bunch of different ideas and they're drawn up a little bit better with some shading and look more realistic. And then you get into 3D concepts. So not a full production model, it's a conceptual model. Then you have to create a production model so you can create tooling, you can machine it, you can do all these other things downstream. And then you might have to create renderings to be able to sell it to the end customer and market it and so on. Now, the traditional design process has a lot of different options for software in each of these different areas. Obviously, hand sketching, you got pen and paper, but if you're doing 2D composites, a lot of people are using Illustrator and Photoshop. For 3D concepts, you might be using Rhino or Modo. We fit into the SOLIDWORKS production 3D models, but there's other, obviously, parametric modeling software. And then for rendering, we have 2 of them, Visualize and PhotoView 360, but there's others. So what this means to you is when you go from that sketch to the end of a manufacturer model, it's very, very disconnected. What you aren't able to do is utilize what you did in the step before to move it forward. When you sketch something on a piece of paper, you can't utilize that sketch for your concept model. Okay, they're very, very disconnected. So your process looks like this. You get a little ways and it kind of falls off. You get a little ways and it falls off. You kind of have this start over process. Now that's really where Industrial Designer comes in. Let's just look at the three main portions that we're trying to accomplish with Industrial Designer. Freeform design, concept sketching, and parametric and direct modeling. Now, there's softwares to do all three of these. Okay, obviously SOLIDWORKS is parametric. What we are trying to do is be in the middle. We want to be able to do concept sketching. We want to be able to then take that to freeform design, and then be able to create parametric and direct modeling within Industrial Designer and in conjunction with SOLIDWORKS as well. So we're in that center sweet spot that is going to make it so you can utilize everything all the way through the process. Now, here's what customers are saying about that process. You know, if you have a traditional process like this, the tools don't talk very well to each other. Like I mentioned, if you're using Adobe Illustrator to sketch something out, you're probably not reusing it in other programs to create your concept models or in SOLIDWORKS. You're starting over. If you're using SOLIDWORKS or other products to model surface models, you know, some people are just not comfortable there. You know, think that requires a PhD to create a nice surfacing model, so they'll outsource it. And then it's hard to collaborate and communicate. When you've got all these concepts or all these ideas, how do you show somebody everything you've got? So that's what we're hearing about the process. Now, I want to introduce you to a company, and we'll talk about what their progress was like. The Center for Advanced Design, they're in the U.S. They build motorcycle or biking helmets, and what they wanted to do is just accelerate the development phase, improve flexibility, and streamline their communication. It boils down to this: having a better gap between the industrial designer, somebody coming up with the shapes, and the mechanical design to finalize the tooling and all the other pieces on the back end. How do we go from one to the other a lot easier? We'll talk about what they did a little bit later. Now let's actually take a look at the product now. Now I'm going to illustrate this really in 3 steps. We only have 30 minutes today, so I want to make sure I get through this fairly quickly. I want to start out with talking about the sketching. We're going to then get into how we turn that sketch into a shape and develop our contoured shape and share it. And then we'll talk about the refinement in SOLIDWORKS and industrial design. So starting out in sketching, we're really dealing with ideation sketching, coming up with those concepts. We can do both freehand and parametric sketching. When I say freehand sketching, I'm talking about pen and paper. When I say parametric, it's like sketching we have in SOLIDWORKS today, where I have lines and arcs and some sort of geometry that can be utilized for creating parametric modelers. We can do both in industrial design. They have intuitive controls. So let's take a look at what that looks like today. So here I am in SOLIDWORKS Industrial Design. You'll notice off the right-hand side, we have the panel for our 3D swim community for a kitchen utensil design. We're designing a new apple core. And at the center of our apple core is a SOLIDWORKS model that was designed previously. We're able to bring that in. What we're going to do is typically what we do in SOLIDWORKS, we're going to start a sketch. The difference is my sketching is freehand. Now this freehand sketching or concept curves can be done with a mouse or with an external device, an input device like a Wacom tablet. Now what you're seeing happen here is the user is able to select the colors and the line weights of the sketch lines. And they're just kind of drawing in the general shape. Again, this was done on a typical plane, so a 2-dimensional plane here. When they get the general shape, you can go ahead and start to adjust your color, darken it up, change your line weights, and really narrow down the design shape that you want. You can see that it really is your pen and paper. Now, you'll obviously get to a point where you'll want to do things like mirroring. Functionality in Industrial Designer just a little bit different. We use a plane to mirror across, but I'm able to have that concept sketch live as a sketch like it would in SOLIDWORKS, but here in Industrial Design. Now I can continue on and start sketching on other planes. Now those planes can have parametric sketches as well. So there I just placed a circle at the center of my part, and my apple core is going to be based around that shape. So once again, we'll select our line weights, select our colors, and start to sketch the shape from this top direction. Now, if you've never used a Wacom tablet, they are also sensitive to pressure. So as you're drawing, the harder you push on the tablet, the darker the line is going to be, and the lighter you push on the tablet, you'll be able to really get the sense like a pencil and paper is going to be. So once again, there's some mirroring involved here. There's a cutout in the handle that we're going to create as well. So we want to kind of draw in so everyone's aware that that is going to occur. And we'll go ahead and finish up the second profile in our concept sketch. Now, we still have really one more that we have to do. We have to kind of understand what this thing's going to look like from the other direction as well. So we'll do one last sketch here. Notice how we can see the other two sketches like we have in SOLIDWORKS. I can utilize those as reference to get my heights and information the way that I want. So the hope with the sketching portion of industrial design is that you can move away from the pen and paper and get as much of this ideation process or development process right here in the 3D environment of industrial design. Once you have that in that 3D environment, as you'll see here in just a moment, we'll be able to start to collaborate with others using the platform. Now, the community that I talked about earlier for our kitchen utensil design allows us to add media and questions and blog posts. The blog posts can capture snapshots of existing designs in different points of view so that I can illustrate a concept to the rest of my coworkers. Okay? Now, when it's published, those coworkers can log in from other devices. So here's just a window showing a coworker logging in maybe on a tablet or a cell phone. Maybe you're out at the coffee shop and they've got a computer for you to access. Well, you know what? You can log in using your login and get access to that community to be able to see. They can comment back and you can see those comments from inside of industrial design. So very, very powerful connection between the softwares. That's the sketching environment in industrial design. Now, we like to say that this is like your digital napkin. You can explore more ideas, turn on and off different sketches, do as many as you need. Also work around existing CAD models. The blades for our apple core are SOLIDWORKS models. They're something we used in a previous design. I brought them in to industrial design and I can work around them. You're going to be able to get feedback sooner. As you get these general shapes, you don't have to worry about getting it 3D printed. You can get this thing out there and allow people to comment really, really quickly. And this will replace some of those disconnected apps, your Adobe Illustrator or Photoshop, where you're doing some sketching on a tablet in those products. Now you can sketch directly in this tool. Now let's talk about the meat and potatoes, and that's the Freeform Design part of Industrial Designer. Now, as you watch this apple core come to life here in a moment, I want you to think about how you would do this in SOLIDWORKS. How you would create the surfaces. Would you sweep them? Would you loft them? Would they be boundary surfaces? And how would you make sure that the surfaces all matched each other? Now, in the world of surface modeling and freeform shapes, there's a lot of talk about surface continuity, and there's different levels. In Industrial Designer, all surfaces are C2 continuous, which is higher than tangency. So it's curvature matching, and you'll see that as we go along. If you've never heard the term subdivisional modeling, you'll see that in just a moment. Industrial Design is a sub-D modeling tool. It'll allow you to visualize your shapes in 3D and virtually model these organic shapes. On top of that, as we just discussed in the concept sketching, we can get that feedback very, very quick when there's an issue. So let's take a look here at our blades. We've got some more sketches in there to give a little more shape. But what we're going to do is we're going to start from what we call a primitive, a free-form shape where we control the number of segments in this free-form shape. And I'm only going to have this at 180 degrees. All of these segments, or something we call cage or cage points, can be used for push-pull drag of subdivisional modeling. As we orient this, I'm able to select a couple faces that are segmented in a location and use something we call the robot. Now the robot has a series of tools built into it. Depending on how you grab the robot and how you pull the robot, it will start to pull those cage points. While it's pulling the cage points, you'll notice that all surfaces related to it maintain curvature to each other. So there will always be some level of curvature. You can always re-grab and readjust. I'm just going to shorten this thing up a little bit. Sometimes you'll want to take those surfaces and break them down even further. If I look into the end of those, I broke those down into smaller surfaces, and now I can perform something we call an extrude. An extrude is very similar to what we do in SOLIDWORKS. We're connecting two pieces. Because I picked them opposite to each other, it creates a bridge between them. Now all surfaces that I have selected will be push-pull drag, and because of the continuity of the surfaces that it has to maintain, it automatically has all the surfaces with nice curvature. The adjustment of the robot can be rotation as well, and it's all dependent on the robot points that are the cage points that you select during the change process. So we're using the concept sketches, you can see, to get that shape to match. If we look at this thing from the top, we need to shorten this thing in a little bit so that it matches the size of the hole that you would expect. Maybe remove a little bit of material. Now this is the one that I always look at. How would I create the backside of that handle in SOLIDWORKS? That's a tough one. Once I have the general shape, I can start to do a little bit of the cleanup work. There's some selection tools like Select Edge Loop, and I can use that to sharpen an edge. So I can create a straight edge. I can then select that loop once again and use my robot to move the surfaces of that loop. Notice how the curvature must be maintained, but the sharpness of the corner is maintained as well. Okay. Now we're going to make some changes to the side here using a tool called Quick Align. Quick Align, you select your cage points, and then you're able to just sketch a curve, and it will align those points to the curve. You'll see it kind of jumping around. This is a nice way to change the shape and to look at different ideas by aligning those vertex very, very simply. And when you get what you want, you can kind of see what it's doing there as it's aligning it up to a virtual surface. Now, if we look at the top of this thing, it's a little more squared off than we would expect. By grabbing the the white endpoints of the robot, I'm able to scale symmetrically. So you'll see it'll pull in both sides at the same time and give me kind of that rounded off shape at the end. Continuing to do some refining work, I can go ahead and split existing surfaces. I want to create a thumb detent in this case. We can take those surfaces, split them up even further, and then clean it up by using the robot. Okay, I'm going to want to pull those surfaces in and indent them in slightly and even sharpen the corner a little bit so that we have room for a nice little thumb detail. The other part I think you'll probably notice about industrial design and really SOLIDWORKS is the way that we utilize the interface with the context-sensitive menus, and you can see them popping up as I'm working here. You make selections right there at your cursor. It makes it very easy to do what you want to do and get access to those commands very, very quickly. There's a nice little detent in our end of our apple core. All right, just cleaning this up just a little bit. There we go. So that part of industrial design, very, very powerful. It's your subdivisional modeling, so your complex shapes. I've seen some good surface modeling users in SOLIDWORKS, but you're not even going to come close to be able to create the shapes that you can create in industrial design in the speed in which you can do it. So it's a tool purpose-built for that. And that's the subdivisional modeling. The design variations, very easy for me to save that model and go off in a different direction and create a different handle or a different shape or adjust something a little bit differently and get approval on those different designs. We used our sketch. We didn't throw it away. We had that concept sketch, so we used it there for reference in the top or the right of it so we can get the exact shape. And we're able to collaborate in the design just like we did in the sketch. We can take pictures and post them into our blog and have people talk about the design. Now, one of the other parts that we discussed in the process was rendering. Now, I could certainly take this model into SOLIDWORKS and render it using the tools that we have like PhotoView 360 and Visualize. But we also have, as part of the industrial design product, CATIA live rendering. So there's a renderer that runs directly on the platform. Here's just some examples of some simple images that were pulled out of there. I just wanted to make you aware that the rendering does happen here as well. And the reason I bring this up is because sometimes if you're an industrial designer, you're not a SOLIDWORKS user. So you won't have access to PhotoView 360 or Visualize, but you still need to do rendering to give some nice images to output. Now let's talk about the last piece before we close here. The interoperability and how we refine the model to make it useful for manufacturing, to make changes in SOLIDWORKS and add other parametric features, and go back and forth between the two. We need to be able to add the refinement and export to SOLIDWORKS. Now I have just a different example here. This is just a bottle design. So inside of industrial design, if I go to the share, I can export an SLD XML file that can be opened up inside of SOLIDWORKS. So that file, I'm going to pause this for a second here, shows up, if you look where my cursor is here, on the left-hand side, as an imported feature inside of SOLIDWORKS. Now, it's a SOLIDWORKS model essentially at this point. Its surfaces are intact and very nice. Imports very, very well. I can start to do things like adding fillets, shelling this thing out, adding maybe some more fillets to the base. When it comes time to make a change, this is just showing all the different features, like a loft for the neck and some fillets that were added. When it comes time to edit it, you go ahead and go back to your model in industrial design, make your change. In this case, added a cutout in the handle. Inside of SOLIDWORKS, you just edit the imported geometry feature and you browse to the new model. And the software is going to map all the features back so they're all intact. You can see the lofted bottle stays intact. So when it comes to interoperability, there is a back and forth. No, you don't get all the features from industrial design in SOLIDWORKS, but it is able to map the features back and forth. That being said, how do we get SOLIDWORKS models into industrial design? Well, very similar. I import a SOLIDWORKS model, I browse to it, and it will bring it in. Now, once it's in, I can right-click on it, and there's going to be a button that says Edit in SOLIDWORKS. This will essentially open up the two products side by side. I will continue to make my edits in SOLIDWORKS because it originated in SOLIDWORKS. But watch what happens when I click over to industrial design. It knows that it's changed, and it goes ahead and updates it. So there's absolutely a relationship here. Now, this is just illustrating some of it. Now, we have multiple parts in one file and mates inside of industrial. You know, there's relationships that can come into SOLIDWORKS as well. So this is a small piece of what really is going on as far as relationships. So those are the four things that I wanted to illustrate today. Wanted to make sure everyone had some time to get a look at industrial design. We want to be able to add those details without CAD rules. When you get into industrial design, there's no CAD rules. It's push-pull drag. It does have a seamless workflow with SOLIDWORKS. You can create parts that can be manufactured. Okay, lots of benefits in all these steps along the way. Now, remember that company, Center for Advanced Design? Well, they are using Industrial Designer. They were able to accelerate ID development by 60% just by removing the disconnected apps. Accelerate your handling of design changes and the communication. You can read the quote there, but it's very simple. You're taking the disconnect away. You're making it easy for an industrial design to make it into mechanical for tooling and downstream. Okay? So that's my message today. A note before we close, I want you to make sure if you do talk to your sales rep about this product, ask about industrial design test drives. We do have on-premise test drives where you can come into our facility and run the software, but we also have 30-day test drives on the cloud where we can just get you set up and you can run the software on your own time wherever you want. So I want to thank you for coming today. If you have any questions, post them in the questions section. Otherwise, thank you, and we'll see you next time.
Don't forget to check us out on YouTube, Twitter, Facebook, and our blog for more great content by clicking on the links in the description below.